It's now my great privilege to introduce today's keynote speaker, Indy Burke, who is the Dean of the Yale School of Forestry and Environmental Studies. I'm a graduate of the Yale School of Forestry and Environmental Studies myself, with a graduate degree in ecosystem ecology. So I'm especially proud that Indy is our new dean. And it's not just because she's also an ecosystem ecologist and we share a love for understanding the intricacies of the carbon and nitrogen cycles in this time of climate change. It's also because she is an amazing leader and an innovative strategic leader for the school. If I were to read her list of scientific accolades or tell you about her remarkable strategic planning process, you wouldn't have a chance to hear her speak. But instead, I'll note one of her other very important qualities, and that is she's a gracious and diplomatic leader. And especially in today's climate, I have a renewed appreciation for the importance of these leadership qualities. Now, I will note that Indy is an expert bow huntress, so she certainly knows when to wield her weapons. But exactly that wisdom of knowing when, how, and what tools to use is something we so desperately need from our leaders today. Thank you, Indy, for being a world-class scientist and an amazing leader for the students and the faculty working across academic disciplines at the Yale School of Forestry and Environmental Studies. Thank you, Indy, for being that leader for all of us and for coming to speak with us today. Please help me welcome Indy Burke to the stage.
Thank you, Brooke. Senator Durbin, Jerry, Stephanie, conservation leaders, conservation advocates, alumni of the Yale School of Forestry and Environmental Studies, and former students. I'm so happy to be here in Chicago, your beautiful city. Today, what I'd like to do is talk about the relationship between climate change, urbanization, and conservation. Our planet is in the midst of its first geologic epoch dominated by humans, and we call this the Anthropocene. My theme today is that in the face of rapidly changing climate, rapid urbanization, there is ever more need for us to focus very intentionally on conservation. Greenhouse gases have been increasing since the beginning of the industrial age. This is leading to rapid climate change. In addition, urbanization is happening at an astonishing rate, and I'll talk to you a little bit about this worldwide, but also in the United States. And those two forces provide a serious impetus for us to engage in conservation and to be smart and intentional about our conservation. If we do that, we can have positive impacts on mitigating climate change. So let me talk about each of those things briefly, climate change and urbanization, and then I want to show you some of the spatial linkages between urban areas and rural areas that are changing so rapidly and that affect the decisions we can make about conservation. As you know, greenhouse gases are increasing rapidly. This figure shows carbon dioxide concentration since 400,000 years ago, found in the Vostok ice core. You see those cycles that Stephanie referred to. Those occur naturally as a result of the Milankovitch cycles, or the tilt of the Earth. And we now, since the industrial age, have much, much higher carbon dioxide concentrations than any time in the last 400,000 years. In fact, if you look at that red line where it says current level, this slide is from a few years ago, and we're far beyond that. We're off the top of the graph up there where the star is, over 400 parts per million at this time. The consequence of those increases in carbon dioxide concentrations are an increase in temperature. This is a figure of the Intergovernmental Panel in Climate Change report that came out last week. This is a figure of temperature versus time since 1960. And the axis there, the y-axis, shows changes in temperature from a normalized time about 1950 there And if you look carefully, you can see that we've already had 1 degree of warming, 1 degree centigrade of warming. And the report suggests that in the next several decades, no matter what, we will reach 1.5 degrees Celsius increase in temperature. And that in order to avert disastrous consequences, we must take a great deal of action. And this figure shows 2 different emission scenarios: through reducing fossil fuel combustion, through engaging in wise changes in land use to sequester carbon, and indeed, ramping up our ability to store carbon using engineering technologies that so far have not been proven. 17 of the 18 hottest years in the record that we have happened in this century, which is not much more than 18 years old. Those increases have resulted in temperature-driven mortality, decreases in water availability in desert areas, increases in hurricanes and floods, and sea level rise, sea surges, and most concerningly, very difficult situations for the poorest and most vulnerable populations on the planet. I love to put New Yorker cartoons in my talks. This one says, "I finally feel I can accept the things I'm too lazy to change." And the point here is that climate change is a consequence of human behavior, and we've known about it for a while, but climate change continues to amplify. So far, we have not, as a society, engaged in willful decisions to reverse this. But the positive message I would like to give you is that we have an unprecedented opportunity right now to begin. So let me talk next about urbanization. Urbanization, or the rate of growth of cities, is both influenced by and influences climate change. Urban areas take up about 50%. About 50% of the people on the planet live in urban areas, but 80% of the economic productivity of the world happens in cities. 70% of the energy is consumed in cities, and 70% of the greenhouse gases are produced in cities. So this is one major contribution to climate change. Another is through urban heat islands, and that is that the pavement and other impervious surfaces in cities absorb shortwave radiation and become heated, get rid of that as infrared radiation, which is then trapped by the atmosphere and the greenhouse gases. So urban areas contribute quite a bit to climate change in addition. They're also influenced by climate change, and I spoke to the influences of climate change on public health in cities and the vulnerability of cities to hazards such as flooding and other major events, and we have certainly seen a lot of this in recent days even. We live in the age of urbanization. So this figure shows from 1700 to 2100 the world population. The blue is the rural population, the gray is the urban. In 1800, 3% of the world population lived in urban areas. Today it's 50%. If you look over there, that first bar after 2000 is 2020. It's about 50%, and you'll notice that this goes into the future. So the demographers predict that by 2100, 88% of the world's population will live in urban areas. Now, this happens for 2 reasons, and one is reproduction within cities, so populations grow naturally, but the other is huge migration across the globe from rural areas into urban areas, because urban areas have this high level of economic activity, jobs, and then the perceived quality of life is much higher. So demographically, a lot of people are moving from rural to urban areas. I'm going to show you a video now of the past. So this is from the beginning of time up until the present. I think we have all the cords plugged in the proper place, so let's give it a go.
Historians at Yale recently mapped the explosion of cities through time. This is what the world looked like at the heights of the Roman Empire, And by the time Amsterdam was born, the sprawl seems dramatic. Until you see what's happened since the Industrial Revolution.
Now, the size of those dots represents the population density. But the next question is, what about space? And I'm going to spend most of my time now talking about the spatial configuration of cities within their regions and how much space cities take up. So it's not just the number of people that influence city growth, it's how much space each individual person takes up. This is a graph of average home size in the United States. The trend is similar across the world. The United States has the second highest average home size, second to Australia, just by the way, I looked at the data this morning. From 1973, with an average house of about 1,600 square feet, to today, when the average house is upwards of 2,800 square feet. So this is a lot of space taken up per person, and interestingly, the average household size has gone down in the United States. So that means each person takes up more area than ever before. The current rate, this is now, not in the future, but the current rate of urbanization is 20,000 American football fields, I could make a lot of other analogies, are becoming urban every day for 30 years. This is about the size of Providence, Rhode Island, every day. And the increase in urban land is projected to be about 2.3 million kilometers squared by 2030. So if you look at the data there, I want you to focus your attention just on the average increase, and at the bottom line there it says an average increase of 259% between now and 2030. That's an awful lot. You'll also notice that Africa and Asia have very high rates of predicted growth. So I'll show you an animation now. We in the Yale School of Forestry and Environmental Studies have a very strong urban program. We were one of the first to start an urban forestry program, and we now do a lot of work both in New Haven and across the world in urban science. This is a satellite image currently of night lights across the world. And our team, Dr. Karen Cito and others, produced a simulation of what this will look like in 2050. And that's what it'll look like in 2050 at the current rate of growth. So this inspires a lot of attention to conservation. If we have that much land area being converted to urban, it's coming out of natural areas and working landscapes. And so we need to think carefully about how to plan for smart cities. So let me get to the third part here. How do we think about conservation and within a larger context of a region? We heard earlier about the need for biological diversity to protect our ecosystems for a healthy planet and for ethical reasons. We know that there's a human-nature relationship, that the more nature that is available to all of us, the healthier we are. There's a need for local resources. The amount of greenhouse gases we produce is directly related to the distance our resources travel to get to us. And we need to conserve in order to mitigate heat islands and mitigate other kinds of natural hazards. So let me just say, I mean, you all know this stuff by heart. You could give this part of the presentation for sure. But the health benefits of nature are many. Urban forests, for instance, result in better air quality, in more opportunities for physical activity, which is a big part of human health, more social interaction in different ways, and stress relief. And all of these things lead to much more healthy individuals. So this alone is an impetus for conservation. But I want to talk now about the spatial components of conservation within regions that support our cities. And I'm going to start by showing you a graphic because I'm going to transition pretty quickly to satellite imagery of cities all around the world. And I want you to be thinking about some themes. So this is my morning productivity. I made this morning. So there's a city. There's the suburbs surrounding the city, less dense, bigger homes, right? There's the ex-urban zone, which some of us have thought and written a lot about. That is even less dense, 40-acre lots, well permits, septic tanks, 4 horses on 40 acres. I have a place like this, so I'm not going to be too critical. And then that city and its suburbs and exurbs is supported by surrounding rural ecosystems that include both natural ecosystems and what I'm going to call working landscapes that might be a complex of rangeland, forest used for timber, agricultural, row crop agriculture, or pasture. And that outlying area provides the ecosystem services that support the city. Now remember, cities consume 70% of the world's energy, and the number's about the same for food, et cetera. So the city is sort of this little sink for resources that's supported by the outlying area. Then the cities are producing money, that's the dollar sign, and carbon dioxide. So I don't want you to forget the impact of cities. If we grow that city, the rural ecosystem surrounding it shrink, right? And so we have a bigger impact on finances and on carbon dioxide, but we now need to rely on sources that are farther away, that are from different regions. And it makes you start to think about circles that are overlapping with one another and how much extra space there is to support cities, especially if you think about the growth that cities will have. So mostly today I want to provoke you to think about conservation as a way of addressing those problems. And what I will do is use some satellite imagery produced by a new book by my colleague, Dr. Karen Cito, and her student, Meredith Reba, from the Yale School of Forestry and Environmental Studies. This is a coffee table book, and it's full of pictures of cities using satellite imagery to bring out features of the land to have you understand what happens during urbanization. We're all used to looking at Google Earth images, and that's sort of the visible wavelengths, but satellites today have many, many wavelengths that can tell you a lot more about the features on the landscape based upon what's reflected back into space. I should make a plug for the book. The Chicago Humanities Festival will happen on November 1st, and Meredith will be there to give a longer presentation on the book. So let me present to you just several cities so you get a sense of this rural-urban linkage that is so important when we think about conservation. Who recognizes the city? It's Las Vegas, Nevada, one of the fastest growing urban areas in the country. It's located in a desert. And here is Las Vegas on April 10th, 1976. And if you look at this, you can see a gray gridded area that has some embedded red in it. And the gray gridded area is the urban infrastructure, and the red shows vegetation. Now, this is the desert. So if you're seeing red there, that means that water's coming from somewhere. And it's coming from somewhere to support, mostly in Las Vegas, lawns, golf courses, and parks, which provide all that greenness that can be good for mitigating heat islands. And look to the right over there, to the east at Lake Mead, and you sort of see this straw going from Las Vegas into Lake Mead, sucking the water out. Okay, now I'm going to show you one from October 12th, 2015. The city has grown dramatically, particularly to the north. It's taking up nearly all the flat part of the basin, and Lake Mead has shrunk considerably. So our cities impact the regions in which they lie. So I'm from dryland systems. I can't help but show you a lot of dryland pictures here, but this is another desert city. This is Al Jaf in Libya. And here on the top, you see the relatively small city in the gray gridded area, just about in the center. And because it's a dry area and it needs to have food to support it, there is a fair amount of very efficient agriculture, and that is done using something that's done not so far from here, center pivot irrigation. And you see those circles. This is areas where irrigation is supplied in drop nozzles to preserve, keep it from being evaporated. And you can see on the top right, I'm going to point out that very red area, that very red circle, and then over to the left, you see two very red circles. And my story this time has to do with the heat island effect. So in the next figure, I'm going to show you bands from a satellite that tells you what the temperature of the Earth's surface is. And in this, you can see where the city is. It's white, 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 because that's the heat island effect, where lots and lots of infrared radiation is being displayed from the ground. And then if you look at those little center irrigation pivots, you can see they're pretty darkly colored, as is the natural landscape. So there's a big effect of watered systems and vegetation on mitigating the heat island effect. And you can see this for many, many cities. Here's just another regular band image. I just wanted to show this to you because it crosses international lines. And part of what I want to say very briefly is that cities across the world grow in different ways that have to do with their culture and the way that government policies go. For instance, China is the most rapidly urbanizing country in the world. And in China, in fact, Karen Sito is actually in China right today working with the Chinese National Academy of Sciences. It's easier to design a city because it's very top-down. They don't wait for democracy to work or advocates to get engaged. And if the government is convinced that cities should grow in a way that's concomitant with conservation values, they make it happen, which is pretty interesting. This is El Paso, Texas, on the right side, or the east side, the northeast side, and Juarez, Mexico, on the left side. And it just shows, if you look at that border a little bit, you can see the difference in infrastructure across that border. It's more purple on the US side than it is on the other side. And the entire cities are supported by agriculture on both sides. They're irrigated agriculture on both sides. Now, the book doesn't have Chicago in it. I'm sorry, but I have the kind of position where I can ask people to make things for me. So I asked him to make me a picture of Chicago yesterday. This is the normal band that you would see from a Google Earth image of Chicago, and you look at that and you think, wow, that's a lot of vegetation. That looks pretty good. And in fact, here is the near infrared red and green that show the vegetation surface, and look at that. There's a lot of vegetation in Chicago. You all have done a great job, Openlands and others, in keeping green spaces that mitigate the heat island effect. I asked them to pull out agriculture. Because this shot was taken in June, you can't see agriculture quite as well in that one, so we played with the wavelengths. And now in the yellow, you can see the supporting agriculture in the Chicago region. So again, a resource-intensive city, good growth of green to protect the heat island, and agriculture to provide some of the needs of this metropolitan area. I'm going to show one last city, and this is one of these bad stories. This is Lagos, Nigeria, in 1984. This is a city that is built on coastal wetlands and swamps and lagoons. In 1984, the city was about 3 square miles. It's very difficult to see where that is on the figure. It's right about in the center. You see a little infrastructure developing there. That's a coastline that is protecting a city resource and the humans that live beyond that natural coastline. And here it is in 2015. And if you look carefully along the coastline, you'll see there's quite a bit of development along the coastline. You can see major infrastructure development right at the estuary. And this is the kind of growth that we need to avoid. When cities grow around the world, we need to think ahead about the regional context and using natural systems to protect us from the hazards that are coming from climate change. So let me complete the circle here. When we conserve areas, and we're going now from conservation back up to climate change, when we engage in conservation, we not only improve human health, but we engage in carbon sequestration. That vegetation is taking CO2 from the atmosphere. We mitigate heat islands, and we mitigate floods and other hazards. Coincidentally, Openlands does this stuff. I've been learning more about Openlands, and I'm so impressed with the mission that includes helping communities become greener, using nature to unite communities, advocating for open spaces, strengthening access to local foods, expanding urban forest, and others. And this mission is completely supporting sustainable urbanization. So on the one hand, as citizens of the earth, we need to be terribly concerned about the changes that are happening on our planet. On the other, I think there's some areas for optimism. So we have a mandate to address climate change. We need, as this IPCC report says, we need to work hard to mitigate climate change and to prepare for climate change. And we need to recognize the reality of a rapidly urbanizing globe. It's astonishing how fast the globe is urbanizing, and it's not very well recognized. Those urban areas, that growth has concomitant resource use, dependence on outlying areas, risks to human health because of the hazards associated with climate change, and those are particularly true for vulnerable populations who tend to live in areas that are not protected from those risks, that are not well ventilated, etc. But there are huge opportunities to craft our future. We can design cities that have in mind not only their own growth, but that preserve biodiversity and the working landscapes that surround them, that support those cities, that prioritize equity and protecting vulnerable populations, that are built smart. This is a problem with old cities. Many of the old cities built on coasts did not have climate change in mind when the infrastructure was built. But now we know, and we can adapt our city designs to that. And we can create international collaborations where we share knowledge in urban science from one area with another, recognizing the cultural differences. And we can link urban science, urban development with conservation science and conservation finance. This is not something that has been done broadly, but we have this tremendous opportunity now to think about urban development in a new way. I want to end by saying that in my daily life, I have another source of optimism. That's our students. That's what they do at graduation. I find a lot of optimism from the smart and dedicated new leaders that we and universities all over the world are creating. These are nimble thinkers. They're passionate about sustainable development and conservation and business, and they're experts who are combining their knowledge about urban science with conservation science and planning. They're technologically adept in addition to passionate, and I think they're going to save our world. Thank you.
Can we have another hand for Indy? Amazing. Indy, and I love your focus, Indy, on opportunities and optimism. Those are so critical in addressing climate change. So thank you again. We really appreciate it. My name is Alan Bell. In addition to my role as a board member of Openlands, I also serve on the board of the Land Trust Alliance, which is a national organization of over 1,000 land trust organizations. And in 2013, Openlands was accredited by the Land Trust Accreditation Commission, a significant accomplishment. Accreditation is a mark of distinction showing that a land trust organization meets the very highest standards for land conservation. I'm pleased to announce that this year, Openlands was reaccredited by the Commission and also noted by the Commission as delivering one of the best applications the Commission has ever seen. So congratulations to the Openlands team. Quite an accomplishment. So before we conclude our program for today, I just wanted to note that complicated events like this just don't happen overnight. I want to thank the amazing Openlands team led by Jess Smazel for their great work and tireless dedication. And staff will be at the door to collect your name tags and your donation envelopes that will hopefully be filled with something, not empty, before you leave. So thank you again for your great support. But one final item, I'd like to thank A New Leaf for the beautiful centerpieces in the middle of your tables. Every year, A New Leaf makes this generous contribution to support Openlands. So thanks again to A New Leaf. Okay, this is the fun part, right? So as is our custom, the person with the birthday that's closest to a certain date can take the centerpiece home, okay? And this person needs to really love apples, trust me. So if you like apples, hopefully your birthday is closest to this date I'm about to announce. So this year's date is April 1st. Oh, someone's born on April 1st. Happy birthday! So whoever's birthday is closest to April 1st can take the centerpiece home. So thank you again, everyone, for joining us today. We really appreciate it, and have a great afternoon.